We have established permanent, rotating outposts in the vacuum of space. The International Space Station has hosted a continuous human presence for decades, marking our reach into the immediate cosmos. Yet the statistics of exploration reveal a strange disparity. More humans have walked across the lunar surface than have ever visited the deepest trenches of our own planet. Although the ocean covers the majority of our home, roughly 80% of it remains entirely unmapped and unexplored. Reaching the absolute bottom of the sea presents a physical barrier that, in many ways, is more difficult to breach than escaping Earth's atmosphere. This cross-section tracks the descent. We move from the sunlight zone through the dim twilight zone, plunging past 4,000 meters into the midnight zone. Beyond 6,000 meters lies a different environment entirely, the Hadal Zone, named after the Greek god of the underworld. Tectonic subduction acts as a brutal geological engine. Massive oceanic plates collide, forcing one crust deep beneath the other to tear open steep trenches. This comparison illustrates the sheer scale of the abyss. If you dropped Mount Everest into the Challenger Deep, its peak would still sit more than 2 kilometers beneath the surface. The Hadal Zone is a hostile environment, actively shaped by the immense ongoing friction of the planet's crust. This scale shows the forces at play at the bottom of the Challenger Deep. While surface pressure sits at 1 bar, the weight of the water at the bottom exerts 1,086 bars of hydrostatic pressure. This is roughly equivalent to balancing the weight of several adult elephants on a single square centimeter of surface area. These conditions render standard maritime engineering useless, as a conventional steel submarine would be crushed inward instantly. Early explorers relied on specialized spherical hulls, shapes designed to distribute that immense force evenly across the structure to prevent a catastrophic collapse. Modern exploration of this zone requires technology built with the same life-or-death precision as a spacecraft designed for a high-gravity atmosphere. The Hadal Zone is locked in near-freezing temperatures and absolute darkness, yet it is punctuated by cracks in the Earth's crust, blasting mineral-rich water at 400 degrees Celsius. Because sunlight cannot reach these depths, photosynthesis is impossible. The standard biological food chains found at the surface cannot function here. Life here relies on chemosynthesis. Specialized bacteria ingest the toxic minerals and thermal heat from these vents, converting chemical compounds directly into biological energy. These volatile hydrothermal vents act as chemical suns, fueling an entire ecosystem that exists independently of the surface world. Even with a food source, a major physiological hurdle remains, preventing living tissues and individual cells from being pulverized by the ambient pressure. Organisms in the trench utilize a specialized protein called piazolite. This molecule acts as a microscopic structural scaffold within the cell, preventing the membrane from collapsing under the weight of the water. This molecular reinforcement allows for the existence of specialized species like the translucent Hadal snailfish and giant deep-sea amphipods. Survival in the Hadal Zone is only possible through these specific biochemical adaptations that protect the integrity of a cell's structure. The bottom of the ocean supports a thriving, highly specialized biome, home to organisms found nowhere else on the planet. Because these trenches are so isolated, nearly every modern expedition results in the discovery of entirely unclassified species. While we devote vast resources to scanning distant solar systems for signs of life, an immense volume of undiscovered biology remains right here at the base of our own oceans. We do not need to look to other planets to find a truly alien world. The most mysterious and unexplored realm in the universe is hidden beneath miles of water on our own seafloor.